ever looked up into space and wondered why it's black? Well, there's two very different reasons for this. Let's start with something known as Olbers paradox. Some of you may answer the question of why space is black with, well, there's nothing in between the stars, so of course it would be black, there's no light source. In a finite universe, yes, that is true. Even in the Hubble Deep Field images, which are some of the grandest exposures of all time, we see that you can look at a seemingly innocuous section of empty space and still find various sources of light like stars and galaxies. But even here, there seems to be gaps between the galaxies. And as we know, galaxies aren't a solid light source. In them are vast distances between even the most densely packed star clusters. And the further away these light sources are, the dimmer they appear to us, as less light from that source reaches our eyes because of the inverse square law. Very basically, imagine a sphere around a light source. Let's focus on a section of that sphere. The intensity of the light reaching that section is reduced depending on the radius from the source, because the further the light has to travel, the more it spreads out over a larger surface area, meaning its intensity to an observer becomes reduced. However, if we lived in an infinite, static universe, a universe with infinite stars, no expansion, and with no beginning or end, the entire sky wouldn't be black, but instead as bright as the surface of a star, or even infinitely bright. This concept is known as Olbers paradox. This is because it wouldn't matter where you looked in the sky, in an infinite universe there would be a light source in that point, with every single micro arc second in the sky covered by a star at one distance or another. But you may say, what about clouds and dust that would obscure the view of background stars? In an infinite universe, these will also be as bright as stars as they receive and reflect so much light. This is one of the grand evidences that the universe we live in is not everlasting, but has a beginning, and so probably also has an end. It is also evidence of the expansion of the universe. The Hubble constant has shown that the universe is expanding at roughly 70 kilometers per second every 1 megaparsec. Given that the universe likely has an age of roughly 13.8 billion years, and because we observe that it is dynamic and expanding, it means that there is a sphere around us on Earth that we can't see beyond, because galaxies that are beyond that sphere are moving away from us faster than the speed of light. This means that even with a telescope capable of infinite magnification, there would be patches of space in our sky that contain nothing at all from our perspective. The galaxies towards the furthest reaches of what we can see have another noticeable characteristic. The further they are from us, the redder they appear. Distant galaxies become redder due to the stretching of light wavelengths through the expansion of the universe in a process known as redshift. The redshift of galaxies can become so extreme that light that was emitted in the visible light spectrum billions of light years away is stretched so much that it eventually reaches us in the form of infrared wavelengths, beyond our eyes' capabilities to see. Which leads nicely onto the second point about why the night sky is black, and it's to do with your eyes. Human eyes are well adapted to life on Earth. During the day anyway, we can see what we need to just fine. You may notice though that at night, without light sources to aid your vision, not only does everything get darker, but it also gets more monochrome. Although you may see the outline of objects and know where you are in a room, you'd be hard pressed to tell what color anything is. However, use a long exposure camera and your camera will pick up that all those objects are in fact still reflecting colors. Knowing that now, it may not surprise you to know that the same goes for our night sky. For our eyes, it is too dim to judge what color it is. but use some clever high exposure photography and you'll see that Rayleigh scattering, or the process that makes our sky blue during the day, is very much still happening at night. You just can't see it. This means the night sky is really still blue. So there we have it. How understanding why the night sky is black or blue can in fact answer some of the great questions the universe has thrown at us, like, is the universe expanding? And as a result, does the redshift of light happen? Without this, it wouldn't matter if our sky was blue or black, because no matter what time of day, the sky would be ablaze with the light of every star in the universe.